see me? Yes, no. All right. Thanks. Just let me quickly share my screen. Are you guys able to see my screen? Right. Maybe we'll wait for another 30 seconds and then maybe we'll go and start. Anybody wants to show their faces, say hello to each other?
Hi everyone, this is Amit.
Hey, Amit. Hey, Haripriya. All right. In the interest of time, let's move ahead. Appandarajan Poornachandran here. You can call me Rajan. I'm here to talk about systems thinking today. The rules for this session is let's make this session lively, have a discussion, and stop me anytime you want. You don't have to wait for me to pass. Let's have a engaging discussion. That's the focus of today's session. All right, in the interest of time, let's move ahead. Okay, so what is systems thinking, right? So we always talk or hear about saying we got to change the political system, we got to change the educational system, things are in a mess, you got to completely have a new system, right? We always hear about it or we talk about it. What is it all about? Any idea? Okay, so let me pitch in and then maybe you guys can pitch in here. So this is nothing new. Let's take an example of an child, okay? So when you give a new toy to the child or a new gadget to the child, what does it do? It tries to play with it, tries to look at it, and then tries to break that one, and then tries to integrate it, right? So that is all about systems thinking. So take the same jigsaw puzzle that what we would have done in our childhood. What is the objective of this jigsaw puzzle? They would have given a picture and we got to replicate that picture and all the blocks would have been disassembled. We got to assemble that blocks, right? So what are we trying to do here is that before we are trying to visualize how it will be. Though we are working on a particular block, we are looking at the whole. We are looking at the big picture. That is all about systems thinking. Am I making sense here?
Yes, yes.
Okay. So quickly moving on to the agenda of today's session, we are going to talk about what is systems thinking. We are going to look at different tools that system thinking uses. We're going to look at the fundamental concepts of systems thinking, why we should work on a system rather than in a system. How do we handle a problem? What are all the skill sets that are needed for systems thinking? As a systems thinker, what is the skill set that I need? And then we are trying to look at what are all the anti-patterns or what are the pitfalls when we try to work on a systems thinking. So this is the broad agenda of today's session. Like what I said, let's have a engaging discussion. Stop me anytime, anywhere. You don't have to wait for me. Okay. So now looking at what is a system. Okay. So system is something that has a purpose. It has a purpose. It is looking at the whole big picture. It has these three intrinsic properties. One, it has to be interacting or interdependent, or it has to be interrelated. So let's take a car. Okay, let's take an example of a car. When I say there are hundreds of thousands of parts in a car, right? Let's take engine as the main part of the car. So when we start the car, the ignition is on, then the engine starts, and there is a heat generated, and the heat generated converts it into energy, and the energy is passed to the different parts of the car. So what happens here is that there is some action that is happening, and there is a kind of a coolant system. So ideally, there is a temperature that an engine needs to have, right? Around 80 to 90 degrees is what an engine, a desirable temperature of an engine. So if it goes beyond that, the engine. So there are some interactions that are happening. So if it is going beyond 80 degrees or 90 degrees, then there'll be some other system called a coolant system, which is trying to always look at what is the temperature. It will try to track what is the temperature of the engine. If it is less than 80, then it will allow it to increase the heat. If it is greater than 80, then what it would do is it would try to push in water, flow of water, to make sure that engine is cooled, right? So there is some kind of flow of information from one part of the system to the other. That is what we call that as interacting. Interdependent is what we talked about. One part of the system can live only when the other part lives. So it is kind of coexisting. One needs the other. The typical example that what we took was an engine, right? Say, for example, let's assume that this coolant or this coolant system is not working as expected. What will happen to the engine? So it will work, the temperature would go above 90 degrees. Beyond a point, the engine would get seized. It will not work as expected, right? So for the engine to work efficiently, it needs another part called coolant system, which has a thermostat which senses the temperature and tries to interact with the system. And if it is going beyond the point of temperature, it will make sure that the threshold is not reached. It will try to decrease the temperature. So if I do not have a coolant system in a car, I will not be able to make sure that engine is working as efficiently as possible. So if an engine has to efficiently work, I need another part in the system, which is nothing but the coolant system. So both are, this is kind of an interdependent where one needs the other. Or say, for example, I give an example of a marketing department and a sales department. Typically, what does marketing department do? So marketing department would look at the kind of how is the market, look at the competitors, give all the data points to the sales department. It will do all kind of road shows. It will do all kind of advertisements. It will not actually make the sales, but it will try to look into the prospective clients, talk to them, give all the data or info to the sales department, where the sales department is actually going to convert that to a sales. So if sales department has to work efficiently, it needs the help of the marketing department. So if marketing department fails, the sales department also fails. So if the coolant system fails, the engine also fails. So that kind of interdependency, one needs the other. If one fails, the other one would fail. That we call as interdependency. When there is a flow of information, whenever there is an interdependency, there will be some kind of a flow of information for the engine to interact with the coolant system. The coolant system will always check for the track the temperature through the thermostat. It will try to find out whether the temperature is desirable or not. So that kind of flow of information is what we call as interacting. Then the third intrinsic property is something like interrelated. Now I have a car, okay? I have an AC. It is all related. Yes, it all belongs to one system called a car, but I can still run a car, drive a car, even without an AC, right? I can still drive a car even without the windshield working. It is related, but each can exist even without the other. That's the point that I'm trying to make here, is that whenever there is no interdependency, then it is no longer a system. We just call it as a collection. It's a placeholder. Let's take an example of a tool kit. I have a toolkit, okay? I pick out a spanner or a screwdriver away from the toolbox. Does it lose the functionality of a toolbox? Yes or no? There are say, for example, there are about 50 tool in the toolkit. There are about 50 tools. I just pick one screwdriver or one spanner out of it. Still, the functionality remains, right? There is no interaction. One is not dependent on the other. That's the point that I'm trying to make here. Or say, for example, we have a kitchen. It's just a placeholder. Collection is just a placeholder. I have a refrigerator. I have a micro oven. I have a stove. Say, for example, I move the refrigerator from the kitchen to my dining area. Does it mean that I cannot have a functional kitchen?
No, no change.
So there is no interaction between the micro oven and the refrigerator. There is no interaction or flow of information between the refrigerator and stove. One is not dependent on the other. If that is the characteristic, then it is just a placeholder, a place where we keep that. It's just a collection. But any system will have at least one part of the as a characteristics where it is interdependent. That's the point. And all the system parts work for the system, and the system will always have a purpose. The purpose of an automobile is to move from one place to the other. The engine is dependent on the coolant system, but the engine is not dependent on the shield, window shield, right? That is all that we are talking about. So are we clear about what is a system now?
Yes.
All right, quickly moving to the next thing. We are trying to understand what are all the basic characteristics of a system. So in a system, you always have a purpose. The purpose of a car is to move from one place to the other. System will have multiple parts. Each of these parts have its own purpose, but no part owns the purpose of the system. Take the same example, engine. Engine is the basic structure for the car to move, right? I have an engine inside the car. Now I take out the engine, keep it away. Does the engine move on its own? Can an engine move on its own?
No.
No.
But the property of the engine was, the basic property of an engine was, inside the car, it makes sure that engine puts it. So what is the point here that what systems thinkers talk about is, though a part of a system has a property, it all matters of how it interacts. So when I take out that part, it loses that power or it loses that characteristics once I take out that part from the system. So though engine helps for the car to move, just because I take out the engine doesn't move on its own. So when I take out a part of a system, the part of the system also loses its purpose. Also, the purpose of the system is also lost. The car is no longer existing if I take off the engines. Am I making sense here?
Yes.
So the second point that what we are trying to look at, if there is no interdependency that what we talked about, let's take the same example of a toolbox. I pick out a spanner. It doesn't make any sense. Still, you have a functional toolbox or a toolkit. But what matters here is that the order in which I keep the part of the system. So we keep the engine always in the front of the car, right? Why do we keep the engine always in the front of the car? Why can't it be in the back? Any idea? I can still have the engine on the back, right? Why don't we do that?
Oh no, that car was designed like that.
No, when the car is moving,
Mhm.
Air that flows will help in cooling the that coolant system. The atmospheric air it is taking for cooling. If we keep it at the bottom, we need to provide additional fan to suck the air.
You're right. So all these automobiles came from a replacement of an horse courage, right? Courage. So what happens? Horse was always in the front. So one mythology was the engine is just a replacement of an horse. It's just on in the front. The other example is like what you said. It makes sense to be in the front because the energy needs to be transferred to the front axle, to the front tires. It makes sense. It's the shortest distance if I keep it the front rather than the back. That's kind of example that you're given. It's perfectly right. But let's take an example of a collection now. I take a spanner from the top, put the screwdriver on the top, take the spanner in the put the spanner in the bottom. Does it make any difference?
No.
That's the difference between a collectioner. So when I don't keep it in an order, the performance of the system deteriorates, but it doesn't matter if it is a collection. That's one fundamental difference between a collection and a system. The other thing is, more important than what we were talking about is, it is not about the parts functionality or the parts purpose. It's how the flow of information goes within the parts. So flow of information. You had a thermostat, you have a coolant system. The coolant system checks for the temperature. It checks whether it is in the desirable temperature. So the stability of the system depends more on the feedback. When I say feedback, it is nothing but the interactions, the flow of information. That feedback will not be there in a toolbox, right? There is no information between a spanner and a screwdriver within a toolbox, but there is some kind of an information that flows between a coolant and an engine. Similarly for any other parts. So these are the kind of examples or kind of basic principles of how a system will work, or rather how a collection would work. Can we move ahead?
Yes.
All right. Now we have a broad understanding of what is a system. Now we will talk about what is a systems thinking. So what is systems thinking? Systems thinking is the way, like what we said, the way how we see, a kind of a perspective, right? How we see how it works, right? So it can be a problem, it can be how an organization works, it can be you're trying to find a solution to enhance a system. So you're trying to visualize something the way how we see, or a more of a perspective of how one part is interdependent or interacting or interrelating with different parts of the system. That's, we are looking at the whole big picture rather than a part. Interaction matters the most rather than the small subparts of the system. Now, one interesting principle in the systems thinking is that no matter how much I improve a part of a system, there is no guarantee that whatever that we are trying to improve for a part of a system, that same kind of improvement will have to the whole system. Am I making sense here? So I'm trying to improve a part, a block, say an engine, just the engine, but it doesn't make sure, or it doesn't guarantee me that the car will get improved. That is all that we are talking about. I'll give you an example. Now, say for example, you bring in all the auto experts to a room, okay, and you ask them which is the best engine that is available. They all have a consensus and they say that Rolls-Royce has the best engine. Okay, you keep that Rolls-Royce engine apart. Then they ask which is the car which has the transmission lines working perfectly. Some says it is Mercedes. Put that Mercedes there. Like that, you're trying to pick each of the best parts in the world, and now you ask the same engineers to integrate it. Will that work? You're trying to build a car based on the best parts. Mercedes has the best engine, BMW, Volvo has the best quality products, some other company has the best transmission lines. So they're all at separated parts. Now you ask the engineers, I have the best engine, I have the best transmission line, let's make a best car. Is that possible? Can I make a best car out of that? The answer is no. Can anybody say why?
Interaction matters.
Exactly. A Mercedes engine will not fit into a Volvo's another product, right? I just cannot even forget the best car. I just cannot even build a car because it will not fit together. That is why we say it is never quality. A system is never the sum of the parts. It's how they interact together. How it interacts together is the most important part of how we build a good system. That is why we say that no matter how you improve a particular part of the system, it doesn't really matter. It doesn't really guarantee you that you're going to have a perfect system altogether. That's the example here. So we've all seen how the market has evolved, right? Did we really ask that we need a mobile? Say, for example, before an existence of a mobile or a smartwatch, did we really needed that? Did somebody ask we needed a mobile? Or say, for example, the money transactions. Earlier, we used to do with coins, then we converted to notes, then we had bank transactions. Today, we are just having a single click and transacting money, right? But if you look at all these technology or all these inventions created a desire, and that desire created a demand rather than whether we really needed that or we really not needed. Nobody asked for a mobile. Nobody asked for a smartwatch. It just came to the market. The innovations came to the market and then people start liking it. So the desires is the one that is driving factor. So that is what systems thinking will always look at, not at the current state. What is instead of? What is the disrupting technology? So systems thinking is more about looking at the future rather than the current state. That's it. Can we move on?
Yes.
All right. So let's take a quick recap of what we have looked at. We looked at what is a system. System is something that it would have an interdependency. It will have interactions, but a collection is something that is just related. That is what is the difference. System thinking is the way how we look at it, way how kind of a perspective model of how we look at each one interacts together. Now, a quick question. So let us take an example of our body. What if I say our body is a collection? Can I say our body is a collection or a system?
System.
System.
Why?
System.
Everything is interconnected with everything.
Exactly. So my heart will interact with the brain. My heart will interact with kidney. My heart will interact with the liver. It will send signals. There is a flow of information. When I pull out the heart's functionality will not work on its own. It will not pump when I pull out the heart from the body. Neither will it allow our body to perform. So it is impacting. It is kind of an interdependency, and there is a flow of information. There is an interaction like what we said. Now let's take an example of a purse. Can I say a purse as a system?
Now it's a collection.
Why?
It is not related to anything. It is individual.
Exactly. So it's just a placeholder. I can have a paper, I can have some cards, I can have coins, I can have some notes. I pull out all the coins, doesn't really matter. It's just a placeholder. There's no interaction that is happening. That's all about. Can we move ahead?
Okay.
All right. Now we're going to talk about different kind of system thinking tools that we use. Historically, what we do is we always try to divide and conquer. The basic simplest thing that what we do is always we try to divide and conquer. The advantage here is that we are trying to split the problems more into manageable pieces so that we can handle it. I'm going to quote examples of scenarios from Professor Akoff, who is a pioneer in systems thinking. So whatever examples that I quote, I'm just quoting from his reference. So he's saying why divide and conquer is not a best way of attacking a problem, but we'll have to look at it at a holistic way. Say, for example, I'm trying to do a graduation in business, okay? I study, say, business law, corporate law, marketing, some kind of finance stuff. So I study as a subject. I'm trying to segregate things. But when I graduate and I move out and start working, the assumption is once I finish this graduation or once we study all these subjects together, the assumption is I will be able to apply all these subjects or courses together when I work. Unfortunately, we don't do that. We focus on an individual part. But when we move out, we have to look at the bigger picture. So this example of how an university works, university is separated into departments, and whichever core subjects that we do, for that core subjects, we try to segregate it to different subjects. But the point here that he is trying to make as a system thinker is that no matter we try to split that into parts, the focus should be on looking as a whole. When I go for work, how will I apply finance and corporate law together? That is all about systems thinking. Or say, for example, a weight loss program. I'm trying to reduce weight. It is simply not about calorie intake or how many calories I burn. It depends. There are multiple factors in it, right? The sleeping pattern, the hormonal imbalance, the health factors. So what are we trying to point out here is that there is no single factor for a problem, or there is no single factor for a solution. There are multiple factors involved. Another example that what we can quote is when somebody asks me what is 2 plus 2, the immediate answer would be 4, right? That would be the immediate answer, correct?
Yes.
Yes.
Now, what if I say 2 plus 2 is not 4? If you go to a mathematician, an expert, he would say 2 plus 2 is not 4. He would ask you back another question. What are you trying to add? Am I adding 2 integers? Then this might be an answer. It depends on the context. 2 plus 2 is not always 4. That is the right way of putting it. It is not always 4. When I have 2 glasses of water, right? Say, for example, both contain the same amount of water and both has a temperature of, say, 2 degrees. Now I'm putting it in another container, all the 2 glasses of water in another container. Will the temperature increase to 4?
No.
Now we said 2 plus 2 is 4. This is just the exact opposite. So it depends on what you are measuring. It depends upon the unit of measurement. It depends on the context. So there is no finite answer or a finite solution. There's no single ready-made answer for every solution. It depends upon the context that the answers or how we solve the problem will vary. That's the point that I am trying to make here. First example is trying to give us that we've got to look at the whole big picture, not just a part of it. Second example is what we are trying to put across is that there are multiple factors to your problem. When you try to solve a problem, that problem might be related to another problem. So there's multiple factors when you're trying to count, and there's no ready-made single answers for a problem. It depends upon the context. That's the crux of this systems thinking. It's a way of how we look at the problem. It's kind of an perspective, storytelling of this. He gives a very good example of an old lady. Let me give this. So there's an 80-year-old lady who is the neighborhood of an university, and literally there is no kind of a medical facility in that university, in that nearby the university. There's no medical facility there. So what is the university trying to do is, okay, let's open a small dispensary there so that the neighborhood will make use of this. So this old lady, 80-year-old lady, always goes for a monthly checkup. She has a bad heart, so she goes for a monthly checkup. That day when she went there, she had a checkup. The doctor reviewed her and she was fine, and she went back home. So her house was she has to climb a kind of a 2-story building. So she climbed. Once she was climbing, she passed away. Okay. So there was a memorial in this university. So this is the context. The first guy who came up for talking about her was some kind of an professor from medicine. He was saying, look, I always told you guys, right? An 80-year-old woman should not come to the hospital. We don't have enough doctors. We should have made a visit to her house rather than she coming up. So then there's another guy, professor from finance came, or economics came, and said, look, we have enough doctors in our town. The only problem is that our health system needs to be improved. She should have a good pension system. We should have a good public health care. That we should take care. Then the third guy came. He is a professor in engineering. So he said, look, why do the 80-year-old has to climb 2-story building? We should always replace all these old buildings with an elevator. We should have an elevator in all these old buildings. The fourth lady, the last lady, she's a professor of human science, and she came up. You guys don't know anything about her. You know, she had a husband. Her husband deserted him. She has a son. Her son is married. He has 2 children. He's well off. If she was staying with her son, she need not have climbed the stairs. She would have been having a good healthcare system, and he would have supported him. So that's the. So each one is trying to give their angle of a problem. Problem is the same. They're just trying to have adjectives to the problem, a viewpoint of why this occurred. You get my point? So there's nothing right or wrong here. What the system thinking allows us is a space to look at various options when we try to treat a problem. Am I making sense here?
Yeah.
All right. Slowly moving up to different types of tools that we use. First, we will look at this iceberg model. Okay. So this iceberg model is more about why do we use it? Is instead of trying to look at events, we are trying to see how the problem actually occurred. What is the source of the problem? You don't have to have a chat. If anybody wants to. What is that? I really didn't get. Okay. Okay. So anybody ask any questions? You can always pitch in. You don't have to wait. So you also don't have to chat here. So first tool that what we are talking about is an iceberg model, where it is talking about how a problem originated. What is the source of the problem? It is trying to find out how a problem actually got created. That is all about an iceberg model. So we all know an iceberg, right? So an iceberg is something like this, right? Most of the part is invisible. There's only 1/3 of the part that is visible. The rest is all beneath the underwater, right? That is how the real world is. The real world, when we see a problem, we don't see to the full extent. We don't know what is going to happen. That's how is the real world is. So we are trying to look at it. So they're trying to segregate it here as the first pyramid structure is a more of an visible one. That is what is visible to us, just like an iceberg, where we have an event. So when you say event, I'm going to give you an example of an assembly line of a factory. Okay, there is an assembly line. They're making some kind of a product. There are multiple engineers who are working on this conveyor belt, and there are multiple shifts that are there. They're working round the clock. Now, say for example, at a particular point of time, they're seeing a defect. What do? They stop the conveyor belt, they stop the assembly line, first correct that, and then proceed with the assembly line, right? So that is nothing but an event. Event is more of a reactive. You wait for a problem to occur. Once that problem has occurred, I try to provide a solution for it, right? It's more of a reactive knee-jerk reaction. This is what is visible. Now, the second pyramid structure is more of a pattern. Now, I see events, right? It's as an isolated events. I see a defective part at this time, then there's a defective part in the evening, then there's a defective part on the night. So in the second pyramid structure, what we are trying to look at is not as an isolated incident. Say, for example, there are 5 to 10 defective items that occur around a particular shift. I am trying to find out what is the correlation between the first defective item and the second defective item. Once I find that, I don't do the root cause here, but ideally we are trying to understand what is the relation between, what is the correlation between. We are not, at this point of time, we are not looking at why it has happened, but is there any relation? In the morning, I had some defective parts. In the night, I had some defective parts. Is there any relation to it? Now, once they try to find during this time or somewhere during this time, there is a defect that is going to come. What they try to do is they do better checks and balance. They do try to do some kind of a QA checks there. So in this kind of an resolution is more of an what do you say? You anticipate something. The first one was more of let it happen, then I will try to rectify it. Here you have some kind of a partial solution where this might happen. These are all happen. I have an historical database where it happens. So I am trying to find out. I may not be able to solve all the problems, but I rectify some problems. So here at the pattern structure, we are not looking at as isolated incidents. We are trying to correlate between one event and the other. If there is a relation, I am better prepared. That's the stuff that what we do in pattern. The third stuff is the structure. Now here, in the earlier part, I did not change the environment. I did not change the design. I accepted the same design. I tried to do some kind of an trimming there to make sure that I partially succeed. Still, I might have some kind of a defects. Now, here in this part of the structure, what they do is they try to do a root cause analysis of why these patterns occur. Why are these defective items occurring at a particular point of time? The scenario here is what? It was happening in the evening, it was happening in the 12 o'clock noon, in the night. So they came to a conclusion that whenever there is a shift change, these defects are happening. They were able to find the root cause. So now they are trying to redesign the system altogether. Okay, one guy is leaving this shift, the other guy is coming in between that time, in between that gap. What is happening is that there is a defective that is happening. So how do I rectify it? So there needs to be some kind of an overlapping between shifts. So there should be some kind of a transitioning that needs to happen between two shifts. So both guys needs to work for a little amount of time so that the transition happens. Now here what we try to do is, we are not following the same design. We are not following the same structure. We are trying to redesign it. We have found the root cause of it. Now, most of the issues would have solved. Now, when we still go in depth of why it has happened, okay, it has happened during the shifts, but what is the mental model? When we say the mental model, what is the psychic of the people who are working there? So one motto or one vision for that company or for that assembly line members was, timing was more important. Quality was okay. That can be a secondary, right? But I have to finish 100 items of products today. That was their motive. Now here, there needs to be some kind of a change in the way of how we look at. Though on-time delivery or timing is important, I just cannot bypass quality just because I need to have an on-time delivery. So that psychic philosophic change needs to happen here. That is what is the transformation that we do. We do some kind of an retrospective here and understand what are the beliefs or what people think when they work. And this was one kind of a scenario. What they found out was, as an engineer, I have to produce this much number of items today. Quality was a secondary thing for them. So that should not be the case. So we are trying to make more than the structure. We are trying to make our vision better. So even when I knew that there is a defective part moving, I am the guy who is going to get into a new shift. It's not my problem. It was on the other shift guy. It's not my problem. So that kind of paradigm shift has to happen. We'll all have to work collaboratively. So that kind of transformation needs to happen. So this is one kind of an tool where there'll be a kind of a brainstorming session. The basic target is, I don't look at a defect or I don't look it as an isolated event, but I look it as a pattern so that I try to identify what is the source of the problem and try to rectify it. So this is one model that we are talking about. Shall we move ahead?
Okay.
Any questions? All right. So the second model is all about a causal loop diagram. Okay. So there are hundreds of tools like this. I just cannot stay or live with one tool, right? We got to know which tool to use at what time, depending upon the context. So there are a number of tools here. That's the point here. So one historical way of looking at a kind of a linear thinking is, let's take the same example of this engine heating up, right? So if it is a linear thinking is always an unidirectional way of looking at things. The car engine heats up, the temperature increases. Okay. Once the temperature increases, am I able to depict that story again? This is a kind of an linear way of looking at things. I'm not able to do it, right? It's always in one direction. The engine heats up, the temperature is increased. Okay, what do I do after that? I'm not able to tell that story. But in a causal loop, it's more about a circular way of looking at things, where we try to say this, okay, engine needs to be at a desirable temperature of say 80 degrees. First it is 20 degrees, the temperature is increased. Now it is 20, I can still increase. So there is a circular feedback loop. The interactions that what we are talking is all about, that what we talked about. It's a more of a circular bidirectional. So causal loop is more of a bidirectional loop where there is a flow of information between two parts of the system, right? So whenever it comes to the next same item, there is some kind of a modified form. First it was the engine's heat was 20 degrees. Then there is an increase. It was 40. Now it is 40, 60, 80. So the input way is modified and it is coming as another modified input. That's all we are talking about. The other thing that I would like to talk about is, let's take I'm again trying to pick from Professor Ackoff's example. Okay, there was an black community school. Okay, it was just specifically for them, and they were passing out, but the real problem was, even after passing out from their high school, they were not able to read or write. They were not functionally literate, right? So this problem was brought up to Professor Ackoff, and he was trying to understand why this is happening. These people are smart enough. They're not dull students. They're smart enough. But when he talked to these students, there are some specific points that he could gather. This is specific data points. One data point was, when they go home, they never saw a book in their house. They never saw their parents reading. When they grow up, they always form a group, okay? After 12 years, they always form a group, and nobody should have a book in their hand. If they have a book in their hand, the same group members would harm them. So they are people with, by culture, they are more of oral than kind of a literary, right? So rap is more of oral. So what he understood was they culturally kind of oral kind of people. Now, how do we make them read? So they came out with a special program where Charlie Chaplin movies or films, documentaries were screened throughout the time of the school, where anybody can excuse themselves and go to the screening and then watch the movie. Once that semester ended, they were able to read. The reason was the documentary or the movie that what they saw had titles in it. So they really did not understand fully. So they had to go to the library and they learned on their own. So this kind of, it's a kind of a story, right? This kind of a scenario is a story where you had a problem and you're trying to rectify it. So we are trying to look at the same thing. So this causal loop diagram will help us to depict that story. Typical flow chart, instead of an kind of a vertical way, this is some kind of a flow chart which is more of a circular way, and where I can depict the whole viewpoint, depict the whole story altogether. Why is there a dropout rate? Okay, there are multiple factors. If it is just linear thinking, I will say students are not interested, quality of instruction, students trauma, stress, and all that stuff. But the same thing, I can draw it in a kind of a circular way where it gives more meaning. More than the meaning, I will be able to depict the flow of information, what information is flowing from one part and what information is flowing to the other part. 20 degrees, yes, the temperature can be increased to 40 degrees. Yes, the temperature can be increased. 90 degrees, no, the temperature should not increase. I go to the thermostat, bring in the coolant. So there is a flow of information. This story can be depicted in this kind of a causal loop diagram. Are we with me till now?
Yes.
Okay. So,
Yes.
yeah, go ahead. Somebody had a question. Somebody had a question? All right. So we were talking about feedback, right? Feedback is nothing but flow of information, nothing but the interaction that what we were talking about. Same example. Look at this example now. Let's take the same example, okay? Engine got heated up. Forget this thermostat, forget this symbol. We don't need to look at it. Heat, 20 degrees. 20 degrees is fine. Target temperature is 80 degrees. There is a gap of 60, increase it. So here what is happening? You're doing one thing, you're trying to repeat the same thing again, right? That is nothing but a kind of a reinforcing feedback. So you're doing something, you're trying to repeat, you're going in the same direction together. So it can be for a good, it can be for the bad. Now the example that what we are talking about is for the good. So 20 degrees, I still increase it to 40. 40 degrees, there is a gap of 40 degrees. I still increase. 90 degrees, we'll come to that later. But reinforcing feedback is, I am going in one direction. I'm just moving ahead in the same direction. Am I making sense here? Or let's take another example. So there is a dropout rate, right? Dropout rate is because there is a decrease in the quality of instruction. Because of the quality of instruction, the student engagement has decreased. Because of the student engagement has decreased, the dropout rate has increased. Again, the example that what we saw first was a kind of a reinforcing feedback, which was going in the right direction. This example is going in the wrong direction, but still this is a reinforcing feedback. Are you able to differentiate between these two? Yes, no. So I repeat, reinforcing feedback is you are trying to repeat what you did before. That can be for a good, which is going in the right direction, or it can be for the wrong direction. The right direction is this: 20 degrees, 40, 60, 80. Here, the dropout rate was increasing anyhow. Because of the dropout rate increase, the quality of instruction also decreased. Because of the quality of teaching was decreased, the students' interest also decreased. Because of the students decreased, the dropout rate also increased. It was going in the same direction. This is not a desired behavior. This is more of a desired behavior. Shall we move it? We can have a recording. It's already live on YouTube, and Rahul will be able to provide the recording too. So no worries.
Okay.
So have we understood? What we learned before was feedback was more of an kind of an interaction that happens, flow of information. This flow of information can be for the good, it can be for the bad. You're going in one direction, you're just trying to repeat, you're just extending that. That is all this example is all about. Forget the thermostat, all that, but just heat is 20 degrees, I move to 40, I move to 60. But the same example, this is a desired behavior. I need more heat. The engine needs more heat. So I'm trying to increase it. But this is an example of same reinforcing feedback, which is going in the not an, and already there is an undesired behavior. I'm still going worst. The dropout rate has increased. Because of the dropout rate increase, the quality of instruction has also increased. Quality of instruction has decreased, sorry. Because of the quality of teaching is not good, the students' interest has also gone down. Because of the students' engagement, students' interest is also down, the dropout rate has increased. So this is reinforcing feedback. Now let's talk about balancing feedback. Here what happens is that you're going in one direction. Now you're taking an opposite directions. Let's take the same example. Heat went up till 90 degrees. Now after 90 degrees, if there is no balancing factor, what will happen? 90 will become 100, 100 will become 200, the engine would get seized. Now I need to have a system where I move backwards. So once it becomes 90, I got to activate my thermostat or whatever sensor so that I flow in water here to make it. So I am trying to stop the heat and I am trying to flow the water here. So earlier I was trying to increase the temperature. Now once the temperature gap or the desirable temperature is, I've got the desirable temperature, what happens is that I try to stop and move in the opposite direction to make sure the system is stable. That's what we were talking about, right? If one system fails, the other system also will fail. So the thermostat is the kind of a balancing factor. Once it reaches 90 degrees, I stop increasing the heat, make sure the coolant system works. So are you able to differentiate between the balancing feedback? Balancing feedback is the one, I was going in one direction, beyond a point, I am trying to rectify, just like how we drive a car. You're trying to make a steep turn. What do you do immediately? You try to balance it and come in back to opposite direction, right? That's the same thing of balancing feedback. You are moving in one direction, you start moving in the opposite direction to make sure the system is stable. That is nothing but balancing feedback. Reinforcing feedback is just the opposite. You're making a change, you're just trying to extend that change, go in the same direction. I just repeat the same example. You're making a steep curve beyond a point. Then what you do, you try to rebalance, right? Simply move ahead and move to the opposite direction. You go to the opposite direction in the steering, right? So that is something that what we are talking about in this balancing feedback. Are you up with me till now? Or you want me to repeat again?
Can you repeat again one more time?
Okay. Forget all this thing. Let's take the same example of a car. I am driving a car, I'm driving a cycle. I am making a steep curve, okay? Beyond a steep curve. So I'm driving it rash beyond a steep curve, I'm trying to do it. So immediately when you make a curve, what do you do? To balance, what do you do? You're
Again, we
driving.
rotate in opposite direction.
That is exactly the balancing feedback. My temperature is 90 degrees. The engine's temperature is 90 degrees. That is the ideal temperature. The temperature gap would be 0. So now I should I increase the temperature or should I decrease the temperature? I have the ideal temperature. I've come to the threshold. 90 degrees is the ideal temperature. That's the threshold. Now still, should I increase the temperature for the system to work properly or decrease the temperature? Just take the same example. Sorry?
If the actual temperature is less than 90, then it can be increased.
No, the point here is it is 90. Should I increase or decrease?
It has to be decreased.
So is this reinforcing or balancing?
Balancing.
Balancing.
Why is it balancing?
Because we are reducing the temperature again.
Forget the temperature, reducing. I am going in one direction. I am just doing just the opposite. That is nothing but balancing. Reinforcing is, say for example, the engine temperature is 0. I am heating it up. Now the temperature is say 40 degrees. Should I increase it or decrease it? I am now 40 degrees. The threshold is 80. Should I increase it or decrease the temperature?
Increase it.
Increase.
Now this is reinforcing or balancing?
Reinforcing.
Why is it reinforcing?
Because we are going in the same direction.
Exactly. Now are you able to differentiate between reinforcing interaction and the balancing interaction? More importantly, what that we need to remember is balancing is for making sure the stability of the system. It helps us to improve the system, make sure that the system runs. Just like our geyser, right? Geyser has a thermostat. Beyond a temperature, it will stop functioning. Once that comes below that, it will stop. So whenever you're trying to move, you repeat, it is always reinforcing. Whenever you're going to move against that direction, move away from that direction to an opposite direction, it is balancing. All that we have to remember is that there is nothing like reinforcing is good or reinforcing is bad. Reinforcing, like what I said, this is for it goes on a desired behavior. Same example this is also reinforcing. It is going in the negative behavior, undesired behavior. So depending upon the situation, what this helps us is that we have to make sure that we have these kind of tools or events that when we do a closed loop, causal loop analysis. Shall we move ahead?
Yes, okay.
Yes.
Yeah. So stop me anywhere if you're so I first depicted this one, this school problem. I have a dropout rate. This is the real situation. Now what I do? What will I have to do? Okay, I have to change the system. I have to give a kind of a solution, right? Now somebody says, I will have to introduce some kind of a new curriculum to make sure that the dropout rate is not increasing, right? So what does he do? Let's take this part only. Let's not worry about the other parts. Let's focus on this part only. We are looking at a causal loop diagram where the feedback system is more of a circular way. It can be either reinforcing or it can be balancing. We are trying to look only this part. My dropout rate is more. So I am trying to do some kind of a change in my system where I am trying to introduce some new curriculum which is easy or which is more motivating or which is more able to understand, people are able to understand. So because of this introduction of a new curriculum, the quality of instruction has increased. When I say, when they put plus here, it means it has increased. When they put minus, that means it has decreased. So when I introduced the curriculum, new curriculum, the quality of instruction has increased. Because of the quality of instruction has increased, the students' engagement also increased. Because of the students' engagement increased, earlier the dropout rate was high. Now, when I say minus dropout rate, what does that mean?
Dropout is decreased.
Decreased. Now, can anybody tell me whether is this a reinforcing feedback or a balancing feedback?
Reinforcing feedback,
Why?
because we are going in the same direction.
How are we going in the same direction? Earlier, the dropout rate, look at this. This was the earlier picture that what we drew, right? There was no introduction of a curriculum. This was the picture that earlier the dropout rate was high because the quality of instruction was low, because the students' interest was low, and that still increased the dropout rate. But look at the case here. Dropout rate was high, so I introduced a new curriculum instead of the original one. That increased the way of teaching, that increased the interest behind the students, that decreased the dropout rate. Is this reinforcing or balancing?
Balance.
Why?
Because we are taking an action to reduce the dropout.
Right, exactly. Are we clear here? So this part is all about balancing. The one that we talked about is reinforcing. Reinforcing is we are going in the same, we're trying to repeat going in the same direction, but this is something like a story, right? So people brainstorm and try to find out this is the solution. So they came out with the solution of a new syllabus. Now they found out that the dropout rate has decreased, which means that it is a balancing feedback. Whenever they keep a hash sign here, that means there is a delay. So to find out whether dropout rate increased or decreased, for introduction of a new syllabus, there was a delay. So that is all it is depicting upon. Okay, are we clear with this? Shall we move ahead? We're clear with this part?
Yes.
So this is what we were talking about, a balancing feedback. Earlier, we talked about a reinforcing feedback, which was an undesired direction. So we introduced a new syllabus. After a time, we made sure that the dropout rate decreased, which was a balancing factor because it was going in the opposite direction. Now, let's come to this part. Okay, my new syllabus got increased. But what has happened is, how do I move this? What has happened is the teacher workload has increased. Is it a good or a bad sign?
Bad sign.
Okay, it's a bad sign. Because of the teacher's workload, the teacher's stress is also increased. Because of the teacher's stress, the quality of instruction has again increased or decreased?
Decreased.
Now tell me, so I introduced We introduced somebody said, let's introduce a new curriculum. We introduced a curriculum. Because of introduction of a new curriculum, workload increased, which was a bad sign. So just look at it this way. You have an event. After this event, which is not an undesired thing. Again, this is also an undesired thing. Again, this is also an undesired thing. Is this a balancing or a reinforcing feedback?
Reinforcing.
Exactly. So here the part that what we looked at, reinforcing, which was going in the desired direction. Here, this is going in an undesired direction. We are trying to repeat what has happened before. The first activity was more of a teacher workload increase, which is not a good thing. Ultimately, because of the quality of instruction decreased, at a particular point of time, the dropout rate also increased. So that is the point that this diagram can depict. This is something like a story, right? Where everybody can pitch in and give their ideas. And this is over time, right? I'm trying to add something and it tells me or depicts me after some time, after introduction of a kind of a new scenario, has this problem solved or not? For the first 6 months, the dropout rate decreased, fine. But beyond a point, after 6 months, the same solution did not work. That is all this diagram is trying to depict. Understand the importance of this, relevance of this. So we first found a problem with this. We tried to introduce a new solution for this. It worked initially, but after a particular point of time, it did not work. I am able to depict this as a diagram, which I will not be able to do in this linear thinking, where it was more of a, this is what where it was more of a single direction, unidirectional. But here, the difference is over time, I'm able to differentiate whether a particular solution has worked or not worked. Are you with me?
Yes.
All right. So same thing. Let's take the same thing. Let's look at this part alone. So because of the teacher's stress, students' relation also got worse. Students' engagement also got worse. Again, reinforcement in the, it's not a balancing one, reinforcement in the undesired behavior. After, so as I said, an ASH is something like, it's a kind of the results are coming up in a delayed way. So because I introduced a kind of a new curriculum, though it solved some points, it was not able to solve beyond a point where there are more stress. So because of the stress, again, the dropout rate increased. Now, are you able to see the difference in the symbol here? B refers to balancing, R refers to reinforcing. Can anybody tell me what is the difference between these two? I again repeat so that you guys can pitch in. You had a dropout rate already, so you introduced a solution to make sure that the dropout rate decrease. So you're moving against or opposite to what has happened. So I call this as a balancing factor. Now, for the same scenario, we are only talking about this one. I introduced a solution, though it was able to solve for a particular point. Beyond a point, it was not able to solve 100%. Because I introduced a solution, it created another problem, which was more of a student stress. Because of that, again, the dropout rate increased. Now, okay, tell me whether this is a balancing or an reinforcing. Is this scenario a balancing factor or a reinforcing?
The reinforcing.
Why is it reinforcing? I'll repeat again. So you had a dropout rate. The dropout rate was high anyway. So you introduced a solution. You made sure that the dropout rate decreased. This we said is a balancing. Okay. This we said is a reinforcing because it was going in an undesired. But this is a desired path, right? You had a solution for it, but the solution was not 100% accurate. Because of that, so after 6 months, the dropout rate decreased, say after 6 months. That's why we put a hash symbol here. Earlier dropout rate was 20%. Because of this new introduction of a new solution, the dropout rate decreased to 5%. Later, after 6 months, there was a stress because of this, which increased the dropout rate. Will you still stick to reinforcing? You created a solution for it. That solution is not working. The solution was working before. The solution is not working now. Will this be a reinforcing or a balancing? Let's go back to the definition of reinforcing. You're trying to repeat something. You're going in the same direction. Then it is reinforcing. Reinforcing can be both for desired behavior and also bad behavior. Same as well as balancing can stabilize the system also. It can also go for an undesired behavior. Now tell me, so I had a good dropout rate, meaning I had a decreased dropout rate because of a solution. It worked for a particular amount of time. After 6 months, it started moving in the opposite direction. Is it balancing or reinforcing?
Balancing.
Why is it balancing?
Because of the introduction of curriculum, in the first case, dropout is decreased. So after some time, the dropout is increased.
Exactly.
So it is opposite to the first case.
Exactly. So what we'll have to remember is both reinforcing can move in the desired behavior or it can move in an undesired behavior. Same as well, balancing we can use for stabilizing the system, but that factor should work, right? If it doesn't work, it will go in the opposite direction only. So that is what it is trying to portray. Am I making sense till now? Can we move? Or if you guys have any questions, we can ask. Or if you want me to repeat again. So let me repeat it again. So reinforcing is something that you're trying to repeat the same like what we do before. Balancing is just moving in the opposite direction. Generally, balancing we do for stabilizing the system, but that doesn't mean if it is not working, it can move in either of the directions for both reinforcing and balancing. That's the point. So this causal loop diagram will allow me to depict, it will allow me to portray what is the problem. So here we try to understand what is the problem. Then we came out with the solution. Then we are waiting for the solution to get executed, trying to find out whether the solution has worked or not worked. In this situation, the solution has not worked. I am able to depict it. I am able to tell it like a story. Now I can find out another solution to fix this problem. That is the advantage of this circular kind of feedback system. Are you guys with me?
Yes.
Shall we move ahead, or you still have any questions? If you have doubts, let's ponder in. Absolutely no problem. You guys are clear?
Yes.
All right, quickly moving. Another tool is more of a behavior over time graph. It's typically a line graph over time. So let me give you a scenario. Okay, there are some kind of a sales that is happening, kind of new products that are being brought to the market over time. They're trying to depict it in a line graph. They're trying to find out that, okay, over time, I'm able to see there is an increase in sales. There is increase in terms of number of products that are released in the market. There is an increase in the sales force kind of resources. I'm able to recruit more people in sales force. But what I am able to see here is, though my sales has increased, though I'm able to bring in new products to the market, if you see the graph here, I'm seeing the profits going down, right? So I'm able to depict this in a kind of a line graph over time, looking at different factors, how that factors are playing around over time. I'm able to depict here. Now, what do we do with this tool is, I'm trying to find out why there is, even after having a good sales, even after having good amount of product releases, why my profits are going down. So I do some kind of a brainstorming, and we try to find out, saying that for all the product releases that what I do, they're all less than 10K, kind of a low volume. The cost remains the same, or the cost remains high, but the number of releases, there are kind of not a kind of high sales or high revenues. The margins are very low. Though the number of releases are high, the margins are very low. The cost of producing that is high. I have a high amount of resources that are working for the sales. Still, I have a kind of a high number of sales. Because the margins are very low, my profits are getting affected. So I'm able to depict this over time on different factors. Now you try to find out, why am I trying to have these kind of product releases which are going less than 10K. So they come out with a thing that there are more kind of from the management, there is more pressure in terms of, I need to produce more products, new products into the market. So whether it is worth or not worth, I am trying to produce. So what this tool is trying to give me a sense is, it is trying to look at multiple factors over time, how it is playing around. What is the correlation? Why one factor is affecting the other? So they're trying to find out, instead of isolated events, they're trying to understand the real reason why a particular variable is getting affected over time. Are you clear here? It's just a line graph where we are looking at different variables, how it is getting affected on a time basis. This is another tool. Are you guys with me?
Yes.
So we saw three tools here. Go. You had a question? Okay. So these are the three tools that we looked at. One is the iceberg model. Iceberg model is the typical iceberg. The real point was, I'm not able to see the full depth of the problem. Without understanding the problem, we try to solve. So here what we try to do is, we are, instead of solving it superficially, we are trying to look at why this problem really occurred. We are trying to look at it, hit at the source. The second tool that what we looked is, I am able to visualize, I am able to pictorially, on a circular bidirectional way, come out with some kind of a storytelling, and all stakeholders getting involved, come out with a solution. The third one is a kind of a line graph, where I am trying to see how a variable gets affected through time. These are the three kind of, there are many tools. I'm just picked up these three tools, where any kind of a system thinker or any kind of system thinking models, they use these three tools. So quickly moving on to recap, we saw the iceberg model, where it looks about the source, causal loop diagram, which talked about the bidirectional, more of visualizing factor, where everybody can get involved. We try to provide a solution for that. I'm able to visualize it at a much easier way instead of a line graph where it is always an unidirectional. Here we try to do it bidirectionally and try to solve the problem. Third one is more of a line graph where I am able to see what is the impact to an variable over time. Quickly going to a question. So I have a car, the car is speeding up from 20 kilometers to 40 kilometers. Will I call that as a balancing feedback loop or a reinforcing feedback loop?
Reinforcing.
Okay, why is it reinforcing?
Moving in the same direction.
Okay, now I have a sensor beyond 40 kilometers, threshold has reached. I will have a cutoff. I will make sure that this speed doesn't increase.
Balancing.
All right. So are we clear with this?
Yes.
All right. Let's move ahead. So the second thing that what we are trying to do is different kind of toolkits. So toolkits is kind of an basic concepts that what kind of a system thinker would use. The first thing toolkit or a kind of a concept that they will look at is interconnectedness. Interconnectedness is nothing but a shift from a linear way of looking to a circular way of looking. That means that is what we saw. We are not looking at a problem at an isolated way. Each one, there is a flow of information between one to the other. Instead of looking at unidirectional, I am trying to look shift towards a kind of a bidirectional way. That is nothing but interconnectedness. Synthesis. So these are all basic keywords or terms that any system thinker will use. So I'm just trying to bring that also. Interconnectedness is I am moving away from a linear way of thinking to a more of a bidirectional causal loop diagram that what we looked at. That is what is interconnected. Synthesis is more we are trying to move away from the analysis part to the synthesis part. That is the same thing that what we saw on a jigsaw puzzle. Though as a child, I am working on a particular block, I will have to visualize, replicate what is there in the picture. I am looking at the whole rather than a particular part. So historically, in a divide and conquer, what do? I am looking at a particular problem, segregating it, making it more simply where I will be able to handle it easily, isolate this thing and try to handle this problem as a separate thing. Rather, I will have to move away from that, have a shift in the right shift in the mindset. Instead of looking at a particular part, I have to focus on making sure I build the whole. So are you able to differentiate between, instead of looking at isolated events, I am looking at a circular loop diagram so that there is interactions happening between one part and the other. That is interconnectedness. The second thing that what we were looking at is synthesis, where I am moving away from analysis. Instead of looking at a part, focusing on a part, I will have to visualize the big picture, look at the whole picture. That is all about synthesis. Shall we move ahead?
Yes.
Okay. So emergence is something like what is the objective of me making that system, right? So emergence is what is the outcome of that system? Why do I make a car? Car has to move from one place to the other. So that's the outcome. So I have individual parts has a purpose, but only once it interacts between together, there is another objective or an outcome that comes as a system. So the outcome of a car is to move from one place to other. That is nothing but an emergence. Feedback loops is nothing but the interactions that we do. We saw this balancing and reinforcing. Causality is nothing but once we saw that in the circular loop diagram, right? Where there is one, we saw that here, right? So you introduced a course, there was the cost was the kind of an dropout rate was high. So I introduced something new, then there was an effect to it. because I introduced something new, there was an effect of an student's trauma. So that is what you have a cause, you make it because of that, there is an effect, you make some change. So there is a change in that behavior of it. That's all they're talking about. So system mapping is all the tools that we looked about. Behavior, iceberg model, causal loop diagram, all these ones. So these are all the kind of basic concepts that a system thinking or a system thinker will work with. Shall we move ahead?
Yes.
All right. So now this is a kind of an saying that we should always work on the system, not in the system. When we were talking about this iceberg model, right? What was the criteria? Instead of working in the system, what did they do? They tried to change the whole design, right? That is all that we are talking about here. Let's take an aircraft, okay? So who contributes more to the in terms of safety? Will it be a pilot? Will it be an air controller crew team? Will it be an aircraft? Which would contribute more? Which would have more impact for the safety of an airline?
All.
Pilot.
Sorry?
All.
All? Yeah, we know all, right? Right. It's also passengers. I can say even passengers have to behave well in an aircraft for the safety of the aircraft. It is always all, but who contributes more? Is it the pilot? Is the air traffic
Pilot.
control? Why pilot? Because he's driving
Because
the
he's controlling the
control.
airline. Yeah.
Okay, but that's not the answer. It's the aircraft manufacturer, because he takes care of the aerodynamics, make sure he designs the system. That's how we should look as a system thinker. Pilot is the one who works within that system. Aircraft manufacturer or aircraft is the one which designs those aerodynamics. It contributes more to the safety of the system. Pilot or ATC team just works for the aircraft. So if the airplane has to be flown safely, the impact, who contributes more in terms of aerodynamics, in terms of how the structure is the aircraft manufacturer or the aircraft itself, right? Pilot can then only make sure that the aircraft can be flown safely. Am I making sense? It's the design.
Yes.
Anybody who designs the system is more important than a guy who is working on that system. Are they clear?
Yes.
Okay. Again,
Yes.
I'm going to take Professor Akoff's example here. A system thinker should always work like an architect. Okay. So say for example, I go to an architect, building architect. I say I need a two-story building. I need a kitchen. I need a kids' room. I need a garage. I need a 3 bedroom. I need 2 baths. I give some kind of an layman's term of how an house should look like, right? So what does an architect do? Does he build rooms first, or does he build a house without a room? I give the specifications. I need 2 bedrooms. I need a kids room. I need a garage. So I'm saying in terms of rooms, this is my money that I can spend. Does he build rooms first, or does he build a house without a room? How does he start working? Will he first make design of 2 bedrooms, then a design of a garage, then interconnect, or will he first design a layout without any rooms? Which one will he do?
Designing a layout.
That is, he is trying to build a house without any rooms. What does it imply? He is looking at the whole rather than a part. Are you guys with me? I said,
Yes.
look, I need a bedroom. I need a garage. I need a kids room. It should be a 2-story building, right? but he didn't look at it that way. He started making a house, creating a layout without a room. Then for this dimension, once he created a layout, then for this dimension, he said, okay, let me have a kitchen of this area. Let me have 2 kids' room. Let me have 2 bedrooms. Once he created a layout, or once he created a house without a room, then he created rooms separately. He did not start with creating a room. That's how, when a problem comes to us, or when we are trying to find a solution, we have to look like an architect, work like an architect, where I first look at the whole, the big picture, first create a layout, and then have separate rooms, not first build rooms, then interconnect it and have as a full house. That's the way of how an architect will look. That's the way of how we should approach a problem. That's the point that this is trying to say. So the purpose of an architect is to make a good house, working functional house. I make a 2-story building, then your kids' room is at the kind of a basement. They're a kind of an age-old parents. They come to the architect and says, look, I can't just go to the kids' room often climbing stairs. Okay, so what does he do? Whenever he's trying to improve a room, he will try to find out whether is that really improving the house. The first point that what we were talking about, whenever we are trying to improve a part of the system, it doesn't guarantee us that it will improve the whole system. The example that where we were trying to disassemble the car parts, it didn't fit in, right? So whenever an architect tries to improve a room, he will first check whether is it improving the house as a whole. Now here, the query that what the customer was asking is, I cannot climb stairs between kitchen and the kids' room. You got to give me a different solution. So what did you do? What he did was, let's reduce the space of the kitchen. Whatever was in the basement, let the kids' room be in the first floor. So what did he actually do? His intention was, it's okay to make a particular room worse if that makes the house better. Are you guys with me? It's okay to make a part of the system worse, or a part of a room worse, if that is going to have a functional house. That's how he will never have a second thought. I can reduce the space of a kitchen if I can accommodate kids' room, because I need to have a functional house. That's how an architect will look at. He will always look at the whole, not a particular part, not a particular room. Are you guys with me?
Yes.
Yes.
So that's how we should work as a team. So that's why we try to look at how an architect works. So the last item is how we treat a problem, right? There's a famous saying that you can never solve a problem. The point here is, once I try to solve a problem, what happens is that that problem will create another new problem, which will be much bigger than that. So solving is not the solution. That's the thing. So in systems thinking, they try to segregate it as 4 items. The first item is kind of absolve. What does it mean is that you ignore that there is a problem. You try to assume that the problem will go on its own. I don't have to do anything about it. Just like our children's fight at home, right? So beyond a point, if they still fight, we get in. Until then, we try to say that let the children fight, let them have their own space, let them fight, and then maybe after a time, then they mingle together. So you assume that I'm not going to make any action. You assume that that problem is going to vanish. That problem is going to go away. That is nothing but absolve. I'm not going to do any kind of an action. The second item, the way of how they look at a problem, is resolve. I am trying to resolve a problem, but that is just good enough. That's based on my experience or trial and error method, or somebody saying that I am trying to solve the problem. It's something like a workaround. It's okay. I've solved the problem. That's it. I really don't know whether that is 100% perfect, just like the example that what we saw in that circular loop diagram. I introduced a new syllabus that created kind of a motivation to the students. It worked for a particular point of time, but then beyond a point, it didn't work. That's the kind of an resolved thing. So again, I'm going to give you an example. Okay, there is an old 50-story building. Okay, and they had lifts, and this lifts took a lot of time. The number of lifts and the number of people who were using that lifts were high, and people were waiting for the lift to come. So everybody started complaining, and they brought in the association of that building, brought in the experts, and they found out that it's an old building. Either you can add more lift, but that's probably it's an old building, so I just cannot accommodate that. And maybe you can now have this automated systems where you have a 20th floor. If there's nobody waiting on the top floors, you don't have to wait. So, but still, in terms of benefit and cost, that is not working. It's an old building. Nothing can be done. Forget it. But the association has to do something, right? So they called in all the floor managers of each of their offices, and it was something like a brainstorming session where the moderator said, "Look, we all know there is a problem, and I want a guy to start with a solution. Okay, the other guys has to second it. They just cannot shoot it out saying that that is not going to work. If you think that is not going to work, you got to give me the way how I can modify that same solution to make it work. So we'll have to work as a team. One guy will come out with a suggestion. The other guy has to see how I can improve that suggestion to make it work." That was the context. Are you guys with me? So that was the context that where they were having a brainstorming session, a typical kind of a Delphi technique or some other technical. So are you guys with me till now?
Yes.
So the first guy told, but the moderator asked, say, "Look, are you guys okay with this? Did you understand fully?" Everybody nodded. The first guy did not really understand the context. The suggestion that what he gave was nothing is going to work, right? The second guy seconded that nothing is going to work. Beyond a point, there was a complete silence because they didn't understand that one has to give a constructive solution and the other guy has to improve that. The first guy who stood up gave a solution that it was not a solution. He just gave a saying that nothing is going to work. Everybody seconded it, gave their own thoughts of why it is not going to work. The moderator did not know what to do. There was pin drop silence. There is one guy who really did not participate. Okay, then the moderator asked, "Why did you not participate? What is your thoughts?" He said that people will laugh at me if I give this kind of a solution. He said, "Okay, we don't have any luxury to laugh at your solution. Go ahead and give a solution." He gave a solution, and the solution was just costed $500. What solution that guy gave was to have mirrors all around the lift. He did not look at that problem within that system. Rather, he looked at around the system. What was the problem? People were waiting for almost 2 minutes for the lift to come. It was more of a boredom. How do I kill that boredom? Fit in mirrors all around, either to see yourself or see others in the pretext. So that then the people were, nobody was complaining about it. Even now, if you see in all as a standard, they will make sure that all lobbies have mirrors to it. So this kind of an example is here, he's trying to give a kind of a solution which may not 100% kind of satisfy, but it is just good enough, more of a common sense approach. The third one was more of you're trying to solve, just like an example that what we saw, right? You had an assembly line, you had a defective part, immediately you stopped the assembly line, you rectified the defect, and then you did not change the design, but you try to rectify it and make sure that the assembly line runs. So that's why we say once you solve a problem, always there's another recurring problem or always another bigger problem which would occur. That's so always a solving is not the solution, but a dissolving is a more appropriate way of rectifying the problem. There was let me give another example that what Professor Akoff says about. Okay, there was a matchstick company. Those days, the matchstick would be something like this, where it's a big kind of a matchbook. Okay, and there is an abrasive here. It so happened that there are many customers who complain that what they do is that they open the cover and then they light the matchstick. It so happened that either all the matchstick got burned and they burned their finger. There are a lot of lawsuits that were happening against the company. The company didn't know what to do. There's a guy who came from outside the company and said, I have a solution. Will you be able to implement it? All that guy told that they all the others before that, they tried, let's put symbols to it. Let's give a writing statement saying that always close the folder and then close the book and then light the matchstick, something like that. Okay, that really did not work. What that guy told, again, the second guy, the same example like what I'm trying to say here is that guy did not look within the system. He started looking around the system. Why is this happening? The question of why is what the system thinking is all about. What if I, instead of it, what change if I do that can actually solve the problem or dissolve the problem altogether? Instead of putting this abrasive here, what will happen if I put it on the back of the matchstick book? That was the solution. So whenever we try to find a solution to the problem, solving is not just good enough. Because once you try to solve a problem, there's always a recurring problem that will happen. It's more of a dissolving a problem where we change the structure. Look at these causal loop diagrams. Look at this behavior over time diagrams. Look at this iceberg models, something tools like that. Redesign the system to make sure that problem never occurs. So these are all kind of different ways of solving a problem. Treating a problem in that way. Shall we move ahead?
Yes.
All right. Okay, let's quickly move ahead. Now we are talking about the kind of skill sets that are needed for a system thinker. One thing is dynamic thinking. What is this dynamic thinking is? We already saw this tool, right? The behavior over time tool. What did it do? It tried to pick patterns and it tried to look at how the patterns worked over time rather than looking at isolated events. So system thinkers take this example of a basketball. Okay, first I need to know how to dribble the ball, right? Then I should dribble the ball, at the same time I should run, right? Then after I learn how to run, I should not see the ball while I dribble because I'll have to look at the opponents. I look at the defenders. Then after dribbling the ball with running without seeing the ball, I have to know at what time I have to shoot, at what place I have to shoot the ball. So typically, a system thinker has to have multiple skills. I'm sure every sport will have. This is the example of a typical example of how a basketball skills need. Similarly, a system thinker needs to have these multiple skills. One is the dynamic thinking. One way of looking at on a legacy way is a static thinking, where I'm just looking at events as isolated events, that what we talked about, right? Here in this dynamic thinking, I am trying to correlate one event to the other. The example that what we saw in the iceberg model is every time 12 o'clock noon, this event is happening. What is the cause of it? What is the relation between it? I am trying to understand the patterns over time. Basically, I am having a sales, but still that sales is not giving me money. Why is it not giving me money? So anything that I look as a pattern rather than an isolated incident, that is the skill set that a system thinker needs to have. The second thing is this system and cost thinking. Typically, when you try to draw this diagram, right, I should know what is the boundary for a problem. Only then I'll be able to solve. I can't solve all the problems in the earth, right? So I should know till what I'll be able to solve, who are my stakeholders. Beyond a point, I will not be taking care of that. So systems and cost thinking is, before you look at a problem, first I need to know what is the boundary of it, who are the stakeholders. Only then I will be able to fix or solve that particular problem. If I don't do this, what will happen is always we'll try to have a blame game, say that these are all external stakeholders, these are all external. So the first thing that what I do is I create a boundary in what detailing I should describe the problem, so that as a team we take responsibility. The third thing is a kind of a forest thinking. Forest will have n number of trees. If I'm going to go in detail, I cannot look at a problem in detail for each tree by tree specific. On a whole, instead of looking at a particular block, I am looking at a whole of what I need to replicate. That is, I'm looking at a big picture. That is nothing but your forest thinking. Operational thinking is, I'm looking at the cause and the effects and the behavior, that what we saw in this circular diagram or the causal loop diagram. Closed loop thinking is also almost the same. We'll look at the third, the last item is this quantitative thinking. Quantitative thinking is, you have many factors. Just because I am not able to measure that factor, I just cannot leave it out. Say, for example, the confidence factor, or say the branding, morale of the employees. I really cannot measure it, but I can still factor it, saying quantitative, it's saying that 1 to 10, what is your morale? 1 to 10, what is the confidence level? Just because I'm not able to measure that, I just cannot exclude it from providing a solution to the problem. I should also take that. That's the point here. Scientific thinking is more about all models, or all whatever models that what we talked about has a flaw. It depends upon the context. Dr. Deming clearly says that every model has a flaw, nothing is perfect, but some are better than the other. So this behavior over time tool that what we looked at will give me to understand what is the problem. All these factors will give me how to create or how to solve the problem. But whether it solves or not, I will have to first test this hypothesis. That's the base rule. So these are all some kind of a skill sets that any problem solver needs to have. Are you guys with me?
Yes.
All right, quickly moving on to the last slide. What are all the kind of an anti-pattern? One thing is we saw all these loops, right? The circular loop diagram and all this. I may overlook it. When I say overlook it, the exact meaning is I may fail to notice whether this reinforcing loop is, whether we need to have whether it's a reinforcing loop, whether it's a balancing feed loop, whether my introduction of a new problem solution is working on it. So all that I will have to see it without fail. So if I fail to notice, my whole system thinking will go on a flop. You guys with me? So I should know whether I need to introduce a kind of a reinforcing feedback, or I should use a balancing feedback, or I should find out whether this reinforcing feedback or balancing feedback really works. So I should not just leave it alone. That's the thing. Does it make sense?
Yes.
The second thing is failure to consider delays. So we should consider that any solution that we give or for any problem, the ash that what we talked about is delay. The dropout rate, just to know that the dropout rate is increased, I need some time to look at it, right? So just like that, once I provide a solution, whether it works or not, it takes some kind of an amount of time. So just because for the first 6 months it worked doesn't mean that it is going to work all the time. So that's the point here. It can change any time. So that's the point here. There is always a delay factor. Anything that you introduce will take some time to work or not to work. And we should always not confuse correlation with causation. That is, just because two things are happening at the same time, that doesn't mean that they both are related. Let me give you a typical example. Always they say that, right? High performing teams will always have conflict. That doesn't mean that any team which has conflicts are high performing. That's just one of a factor. That's it. So again, the last thing is whenever I come out with a kind of a solution, I should first lay out a boundary, and everybody should know that. All the stakeholders should know this is my boundary. This is the playground that I'm going to play with, and then rest is all external entities. So these are all some kind of an anti-patterns. I'm just trying to come to the end. So the takeaway from this session, there are only two things that you guys want to remember. Please remember this. Everything as a part works well, but just because I am going to work on a particular part, it doesn't give us a guarantee to make sure that it works as a system. The example that what we saw is take the best parts out, you combine it. I just cannot even integrate it because one will not integrate the other. The second thing that I want you to remember is think like an architect, design the system, use this reinforcing feedback, use this balancing feedback, or use any of these tools to change the design. We have to think like an architect, not just work in the system. We got to work on the system. These are the two takeaways that I will like you to remember from this session, if not anything else. All right. I am really sorry. I think almost took another hour. I really didn't know. Let's go to the discussion now. Any questions, or if you want to share your experiences, please go ahead. Feel free. I'm really sorry, Rahul. I really didn't see your message. So thanks for hearing me out. Any queries?
Sir, Salman here. In the from the last two slides, you shown system thinking skills, traditional skills, traditional thinking skills versus system thinking skills.
Correct.
On the system thinking skills, there are 4 to 5 like a test. There are 3 categories.
You're talking about this
problem. Yeah, right.
Okay, go ahead. Yeah.
Like each and everything, we have any setup. Like we can practice this. Like any exercise is there.
There are a lot of tools that are applicable. You can look at the guide and look at it. What this is trying to look at is how did we look at it historically? What is something new that how we look at, right? That's all that it is trying to look at. So we have examples of how we look at it. There are literally kind of specifications of how we should work on this forest thinking or how we should work on this dynamic thinking. Dynamic thinking is nothing but your behavior over time. So use that tool. So exactly you can have specific tools for all these kind of closed loop thinking. We have this causal loop diagram, circular loop diagram, right? So similarly for each of this, you will have a tool where you can practice and make sure that we are refining that our fact thoughts.
Okay, thank you.
Any questions? If no, then thanks for hearing me out. I'm really sorry. I think I took almost another hour. I really didn't know. But any other questions or queries before we wind up? All right. Happy weekend and thanks for hearing me out. Thanks, guys.
Thank you, sir.
Thank you. Thank you.